Alright, Midwest Camp, back at it again. I'm sitting here with my buddy Rosie. She's chilling. Anyways, so we're gonna get started. The description of my next kind of series. I really wanted to do this when I discovered it could be done through the last reaction I did, the Perkin condensation. So I could have easily just reduced salicylic acid to salicylaldehyde. Freaking hard to say, man. And, I could have just ended up reducing it and then reoxidizing it if need to, up to the aldehyde from the alcohol. Anywho, this is the route I chose. I figured it'd be a little more interesting and I could put in a new reaction I've never done before that I haven't seen a whole lot of people perform. I've heard it talked about, but yeah. So it's the beginning of the coumarin synthesis, and this is basically what this video is the phenol video. The phenol, whatever, I don't care. Anyways, so we used 100 grams of salicylic acid and heated it to over 200 C. The distillation setup was with no condenser. We redistilled the phenol, collecting everything about 176 C and up for mostly pure product. The reason I did this, you'll see later on in the video, is I had some kind of red organic byproduct left in a flask that I was having trouble removing. That being said, having trouble removing doesn't mean it won't be removed. So apparently the phenol did a great job of removing it from the flask, and it actually traveled up into the reaction mixture. So the crude phenol I'm going to dispose of, but the dry, pure phenol, or more pure phenol, is going to be used in the next synthesis. So, step one in coumarin synthesis is the salicylic acid, time, and heat, and that gives you phenol. That is the reaction we did. Next, we're going to be hitting the Reimer-Tiemann reaction, and that uses phenol and chloroform, and then 3 parts hydroxide to 1 part chloroform. And we're going to use potassium hydroxide in this case. And this is going to, it's a formylation reaction, so it's going to give you that formal group on there, the aldehyde in this case. So it's a salicylaldehyde. Yeah. Okay, so anyways, that's the product on this one. Step 3 is going to be the Perkin condensation again, where we're going to take the salicylaldehyde and the acetic anhydride, and we're going to come up with coumarin. I kind of wanted to draw it like this, and sorry, it's a crappy picture. You can't even hardly see the bend there. But anyways, I wanted to do it like this to kind of show you, like, let's see how we got this. So if you kind of imagine it as the acetyl group is taking up from the oxygen, and then that oxygen is kind of being removed, and the condensation happens there to there. So the acetyl group is added in here, and you get this. I kind of drew it like this at first, so you could kind of see that oxygen right there is from the phenol. And then we got the up to the oxygen. That double bond was the oxygen. So right here we have our acetyl group added in from the acetic anhydride. So coumarin is the product. This is a basis for a lot of blood thinners like warfarin. It's the brand name, and it has this base benzopyranone. I should have wrote it down, but it's like a benzopyranone group. Anyways, so this is the next series of what I'm going to be doing, and I wanted to give it a step-by-step reaction. So part 1 in this video, part 2, part 3. So next step is going to be the Reimer-Tiemann reaction, and I'm going to have to make some chloroform for this. Some points on the first step of the product. You're going to have an acid-catalyzed esterification going on here as well. So on the decarboxylation, you're actually going to produce phenol, but then you're going to have phenyl salicylate, and then we're going to have salicylyl salicylate, which is the esterification of that, and then we're going to have some diphenyl ether, which is the the esterification of phenol with itself. So it's going to be acid catalyzed as long as there's salicylic acid and it's in the reaction mixture. It should catalyze the side reactions. So anyways, that's why we've distilled the product out, and you are generally left with a pretty thick goop. Not even in the oil, it's fairly, I want to call it solid. Incredibly painful to deal with product. So but this is actually pretty easily separated out from the reaction mixture with acetone. So we're going to go ahead and do that, and I will be back with the rest of the video. A quick point out here before we do go to the video, though, is this is my phenol, 28.4 grams. It is slightly off-white, barely off-white. And this is because that little side reaction that occurred, there were some small, tiny droplets of red left up in the vacuum takeoff adapter as the purer product started distilling through. Now that red stuff, I have a feeling it's what modified my boiling point in the reaction mixture. So just a guess, but I think that was it. Anyways, we got some pure product here. It liquefied, got into the container, and then solidified very well. Alright y'all, Midwest Chem, back at it again. First off, things we need. Gas mask, important. We got our setup here. One chemical, salicylic acid, which is a skincare product in most cases. I got one that claimed to be USP, food grade, very pure. Anything else in it that might be a very minor impurity would even be okay to consume. That's why it's food grade. But I wouldn't recommend eating this stuff either. So, anyways, we have phenol synthesis. And I know this has been done to death, but if you hang on till the end of the video, I'll explain where this is going to go. And I have an idea for kind of a cool synthesis. So this is the starting point. We're going to have this reaction, another one, and then a third one to get the end product that we're after. So, but all I've done is I've hit the heat, got this loaded in, and set up my little setup with my Type K thermocouple. And see, right now we're still sitting at 16.2, so things haven't really got warmed up yet. But I will report back as soon as there's something to report back on. Alright, cool. Here we go. Things are happening. So as you can see, we've got a puddle. Nothing refluxing yet, but we'll see how this goes. And finally, here we go. It is just now beginning. Soon I will need the gas mask on, very soon. Alright, cool. Here we go, round 1, down. So, oops. Let's see, you may notice a bunch of red specks, and that's okay. That is not actually from this. It is like a organic byproduct tar crap. I'm not really entirely sure, but it shouldn't really affect anything since we're going for another one here soon. So I'll have to wait for another day for the redist, but that is the yield. It is solidifying, or crude yield I should say. And this crap down here, that's what's left over. There's going to be some phenol, some silicic acid, and probably some water and some phenyl salicylate. There could also be salicylate, I think it was. Anyways, a lot of these, they're acid catalyzed esterifications, and the silicic acid enough on its own can actually induce the esterification. Alright guys, here is round 2, and I've basically, I'm not going to really clean this out for the second distillation, as for one, I'm not really doing analytical chemistry, so to me it's no big deal, but I think most of the stuff in here, the tail end was relatively pure, at least. It might contaminate it a little bit, but we're going to still have a really pure product in the end anyways, because the first fractions that come off are going to be crude, but once it reaches the temperature of the pure, I'll switch this out, and this should kind of go along with the crude mixture, since that will distill off first. So we got this, our phenol, crude phenol. You can see that there. It is solid, also dirty. All this crap was some organic byproduct from a different experiment, so but it's not going to do us any harm here. So we're going to go ahead and get this on. I'll preheat this, and we'll just kind of see how this goes. Alright, here we go. Let me start taking that off. Just kind of put it to the side for now. Thermocouple. Sorry, I should have done this before I hit record, but whatever. Okay, and done. That was hot. So, anyways, we have just a small amount of high boiling liquid. Not really sure what it is. Probably salicylic acid. Not sure. And it did clean all that red gunk off the walls. My impure phenol, although, took a hit. And it's quite yellow. Quite yellow. Bad. It's yellow. I don't even know what to say. I have displeased the chem gods. So we're gonna go ahead and move on to this. Okay, so when this stops refluxing in here, I will hit it with the heat gun, get everything to come over as much as I can. Actually, you know what? Screw that. I'm just gonna go ahead and do this, wash it, and I'll put it all in my phenol waste. Okay. So right there's what we got. I collected a little more. But we'll put it all together and we'll see what we got.